so much, Tiziana. I'm very glad to be here. When I talk, I will take off the mask, if you don't mind. I'll keep my distance from you guys. So I tend to enter this room through the screen, and today I walk with the door. Tiziana did this magic. So we're going to talk today about real space, or solid space, or the space that we populate normally as human beings in real time, here and now. And as some thinkers, philosophers, architects, scientists pointed out, this space that we are aware of continuously happens to be so obvious, so near us, that we have not, we don't stop to think about it, because there's really nothing to understand about it. It's here, the space. And as you begin thinking about it, which we're going to do now, things turn out to be not as simple. So let me start with a simple exercise. An intellectual exercise. I'll ask you a question about what category you believe this space belongs in. What category it belongs in. When I ask you about the category, here's what I mean. It's essentially a definitional question. When I ask a definitional question, I'm implicitly suggesting that you think of the larger group to which this entity belongs. So these glasses is an example of an optical device, right? I am a human being, a biological organism. This room is a part of the built environment. Every time I go through an instance to the category. So my question to you is, what do you believe the category of space is? And I'll give you a minute to think about it. Please write down your answer. Maybe just a phrase. You don't need to write an essay or even a sentence. By and large, I think we have a fresh minute, and most of this needs to be done. So I will ask just a few of you, please volunteer and tell us what you think the category of space is. Please.
It's a space intended for the cultivation and internalization of knowledge.
Say it again. It's a space
Intended for the cultivation and internalization of knowledge.
I see. So the larger category of space is knowledge.
Yes.
I'm looking for a single category. Space is a category of knowledge. So much. Very interesting answer. Other answers, please.
I put volume.
Volume. Space is a kind of volume. Okay. Space is one instance of volume. So if you talk about category in these cases, space is a kind of knowledge together with other kinds of knowledge. And space is a kind of volume together with other things or entities which are volume too. Thank you so much. Other, maybe two more. Yes, please.
Experience.
Space is a category of experience. Okay. Together with other kinds of experience. Such as?
Learning.
Learning is another example of space. Space and learning are examples of the category of space. And one more. Last answer, please. Anybody?
Being.
Say it again.
Being.
Being. Being. It's a philosophical answer. Yeah. Space as a category of being. Well, thank you so much. And if you didn't hear what others were saying in the room, if they collected your responses, I can assure you that they will discover a variety of different responses. And I don't think that is a case where it would be right or wrong about it. These are just illustrations of how something that we immediately understand as a word, space, really means completely different things to many of us. And why do you think it is the case? Why is it the case that we talk about space all the time, and when you hear in a conversation, you hear someone says space, you don't pause and don't say, what did you say space? What did you mean? It doesn't happen. Somehow space immediately makes sense in the context of our daily lives. But when you try to define it, we suddenly pull from very different categories of knowledge, volume. This is theory of knowledge. Here is geometry. Then we have being philosophy, right? So what's going on? Why behind this rather obvious concept there are so many things hiding? Why is it the case? What do you think?
Because our first instinct is to fill, space, a void, with something else. So you go and you think of space as space outside of the world. So it's nothingness.
Yeah. Well, I agree with you. What you're saying is absolutely right, but it doesn't answer my question. Why do we mean different things? If you are right, then everybody will give me roughly the same thing, roughly the same category. Everybody would say something like void or bigger space, universe. We heard knowledge, we heard being, we heard volume. Why is it the case that our minds are sent in different directions when we try to answer this question?
Because I would think it's because our brains are very good at quantifying numerical things, 1, 2, 20, but the lack of things, which would be a space, obviously there's air in here, it's not like we can see it. It leads to more possibilities than just having a single thing that's easily pulled away.
Yes, yeah. So maybe you're getting at something. Yeah. Maybe it is the case that space is not really perceptible directly, just like objects are. I usually, when they talk about this, I have a philosophical object, and Tiziana, I forgot to ask you to bring the philosophical object. For me, the philosophical object is a Granny Smith apple, and apples are perfect for explaining things like this. So, exactly, I just assume that you have an apple, and it's not the case. Maybe you do. No?
No.
Not at the moment. Well, on Thursday, we're going to have another session on Thursday. We'll have a philosophical object sitting right there in the middle of our conversation, right? So, objects that we perceive directly, they have sensory qualities. Apples and other objects have surfaces which reflect light, for example, to make vision possible. Space doesn't have a surface. It doesn't reflect light. It is not perceptible themselves. Spaces are not perceptible themselves. We walk around, we walk through space, supposedly, and we avoid objects, we handle objects, but space in itself is not perceived. Maybe it is intrinsically a category in itself. Maybe this is the beginning of an answer. Would you agree? So perhaps space is a difficult example of defining it to begin with. But also I would argue that it so happened that many different disciplines have studied space. And I'm going to talk about this at more length on Thursday afternoon when we have a public conversation, public talk. I will talk about what I call species of space, because indeed physicists talk about space for centuries. Physicists know very well what space is. I would just argue that the space of physics is not the space of experience. This is not the space that physics is about, at least not how it is construed in physics, because there they talk about metrics. They talk about mathematical equations that capture properties of space, which is called the metric or distance. You might have heard of Euclidean metric, but also there's Minkowskian metric, there's Lobachevskian geometry, and Gaussian metrics, etc. There's a whole world of space in physics, which is not about the here and now. And then there is physiology. There is a science of physiology that has to do with how organisms represent or relate to space. So you may have heard of so-called place cells or grid cells in the brain of animals and humans that are busy representing properties of space for navigating in it and for remembering it. So there is space of physics, there is space of physiology, there is space of psychology, which is closer to what we're talking about, except in psychology, you're trying to describe things in terms that are called public. We do experiments in psychology, we make our discoveries, and we do these discoveries in the format that could be communicated to other scientists, to other psychologists. So it's an objective way of thinking about space. And then there is actual experience of space, which is usually studied as such by a group of, say, researchers or phenomenologists. I mean, the larger discipline is called philosophical phenomenology. We'll talk about it some more on Thursday. So there's also phenomenological or phenomenal space. And notice we have not hit architecture yet. So we talk about physics, physiology, psychology, phenomenology. Phenomenology is a study of experience, direct experience, first-person experience. Then there is what I would call the whole range of instrumental spaces. Instrumental in the sense where space is thought of or used as an instrument for accomplishing something. Architecture is a perfect example of that, but there is also painting, where you talk about space, use perspective in order to represent space, right, on a two-dimensional surface. Think about cinema as an outgrowth of painting, we call it moving pictures. Then there is theater, and there is something magical happening in the proscenium as you move from the audience, which is in here and now, and the stage where, I mean, God knows where they are, in the 16th century, in the 12th century, right? They're in the same physical space, but in the space of the narrative, they're somewhere else, etc. So there is a whole range of, I would call, instrumental spaces. And then in there, there is a space which we may call Proietti, a space of memory and imagination. Since you're in architecture school, you may have heard of Gaston Bachelard's Poetics of Space. Gaston Bachelard was a very interesting French philosopher, part philosopher of science, part psychoanalyst, part phenomenologist. So there's a book which he wrote called Poetics of Space, where he talks about this dimension of space, which is not geometrical, psychological, even phenomenal, phenomenological. And then there is a space of the novel, of the literature. One of the famous characters in that line of thinking is, for example, Mikhail Bakhtin, which is the founder of the School of Formalism and Literature, who will tell you that the history of a particular form of literature called novel, literary novel, and its evolution through time, it's nothing but transformation of how we think about space-time. And he even invented the concept of chronotopos. Chrono, it's a Greek for time, and topos is one of the three terms in Greek, ancient Greek for space. So chronotopos is what we call structure, whose transformation gave rise to varieties of novel. So the reason I'm telling you all of that is that maybe there are so many substrates and schools of thought behind the concept of space that when we just talk about space without specifying in what profession we are, so to speak, we are simply confused. And this is my job, before we talk about space in concrete terms, to remove this possibility of confusion. And this classification that I just reviewed with you very briefly, physical, physiological, etc. And also linguistic, I didn't mention linguistic, right? Even in Greek, I mentioned the three words for space. These are categories of space, because if you answered my question after I've specified that now we talk about literature or we talk about architecture, your answers would be much more consistent with sort of grouping under a more consistent categorical umbrella. So now, after we have reviewed these kinds of space, and I mentioned that architectural space is one of them, let's concentrate on what exactly that is, architectural space, and why we decided at some point to bring science into this. Because architecture is a discipline that has been practiced for thousands of years, right? It's one of the oldest professions. And space was at times a central theme in architecture. As such, it was defined as a theme for architecture only rather recently, in the late 19th century. That's what historians of architecture tell us. Of course, it was all about space to begin with, thousands of years. But space as such became a category in architectural discourse, in architectural theory, rather recently. And maybe it has to do with architecture touching science. The figure of René Descartes was very influential for hundreds of years, and Descartes was an important figure in philosophy and in mathematics. Cartesian coordinates, of course, x, y, that's his invention, at least the invention attributed to him. So, in this context of architecture and science, space features as a central subject. Because science has so much to say about space, and architecture supposedly has so much to say about space as well. Even though in architectural contexts, the concept of space is not subjected to analytical scrutiny. For one reason or another, and I don't think we should spend much time thinking about that. But I would just suggest that we now, as we try to find this connection between scientific thinking and architectural thinking, we start with space. And space as it is experienced, and not as it is conceived mathematically by a physicist who's trying to make sense of movement of immaterial objects in general. So this was just a warm-up. I just told you a little bit about the context of the perceived space. And now I would suggest to think about it very, very concretely, here and now. And this here and now has two sides. It has the sensory side, having to do with how we perceive things, how we sense things, through vision, audition, etc. Through tactile sense too. Tactile sense, we touch things. There's tactile sense, and there's haptics. Haptics is, what the difference is between tactile sense and haptics? Usually what they mean by haptics is tactile sense used dynamically. So if I had my philosophical apple here, I would show you. You see, if you touch the apple, this is tactile sense. When you feel the shape of the apple with your fingers, that's haptics. Okay? So this is sensory aspects of space. How you see it, how you hear it, the volume of it, how you feel it with your fingers when you touch objects, the texture of the walls. You feel it with your feet, so to speak, as you walk. This is all about sensory space. And the other side is motoric or motor. It's a funny term used in our sciences. Motoric means having to do with action. We call it active. Active is a better word, except it's not as specific as motor or motoric. So I have a large number of slides, but given that we are here in the real space, I would rather not do slides, but do little experiments with you. And as we go further into this, we will notice that, that our organization will become simpler and simpler, and at some point it will be ridiculously simple. Because we're going to talk about things that are so primitive and basic that it's almost funny to talk about them. But that's what we have to do in order to understand what space is, because it's so basic and fundamental that I would argue there is nothing more basic and fundamental than that. So sensory space. So when you hear this sensory space, what do you think? what do you imagine I will talk about? I want to delve into the topic of sensory space.
Things that are five senses can find, the elements of a certain subset of space that are five senses can find.
Yeah, but you get access to through the senses. Even though, remember we pointed out maybe 10 minutes ago that space itself is not perceptible. It is sensory, but it's not perceptible by any sense. You cannot see it. Can you see space? Directly. I doubt it, because it doesn't reflect light. Can you hear space itself directly? It doesn't. It doesn't. I think it doesn't. It doesn't reflect mechanical wave, which gives rise to sound. Can you hear space directly? Can you smell it? Can you touch it? When you move real fast, you feel resistance, but that's not space, right? It's air. So you cannot. All the senses that we know, that come to mind first, they're not really giving you direct access to space. There are other senses. Have you heard of vestibular sense? It has to do with orientation in space, actually. So what happens in your head? There's this organ called inner ear, and there are there's liquid there, and as you change the direction of your body of your head, like this, if I close my eyes and was putting in some capsule, and the capsule was tilted without my knowledge, I would still know that my body was tilted. I get it from there. So in a way, that sense is more directly related to space. So there, I would say you sense space, but really what you sense is your orientation, or rather change in orientation. It's not space directly sensed, just like my apple would be sensed directly when there's some light in the room. The apple actually happens to sit in front of me on the desk. So sensory space is getting a notion of space through your senses. So some sort of information is filtered through into your body, into your being, through the senses, and out of that, the concept of space arises. Okay? So let's think what it could be. Let's talk about vision, because we know more about vision, it's more fun. Of course, it doesn't have to be vision. And I'm saying that because I like to talk about vision more, but it's just like a disclaimer in the beginning. I don't believe that space and architecture is purely visual thing. It has to do with all the senses mentioned. So I just want to put it out before we go into vision. And now we go into vision, okay? So vision has to do with perceiving things out there. It's the language we use. And when you probe it, actually, in and out is not so easy to understand in terms of space. But let's take it for granted. There are things out there. We move through the world, there are objects around us, there are things out there which we visually perceive when there is direct line of sight. So last week we had a visitor, Zach Jabara. He was talking about ISOVIST. ISOVIST is an instrument, rather geometric construct, that tells you where things are accessible directly by sight. So let's start from there. When an object is sitting between you and another object, you don't see it because naturally line of sight is imperceptible. It's very basic, but not very interesting because it's very clear. Much more interesting and much less clear is the case where things that appear in a direct light, in direct line of sight, are visible or invisible, which happens all the time. So, for example, I'm looking for the person farthest from me. I'm sorry, could you please repeat your name?
Brandon.
Brandon, okay. So I'll do an experiment with you, Brandon, if you don't mind. You'll be I volunteered you for the experiment, if you don't know. So, I'm going to write something on the board and ask you to tell me what it was, okay?
Okay.
Can you see this part of the board?
Yes.
Okay. Now, tell me what it says.
Does it say cat?
Look at you. I mean, this room is too small.
Just write small. Just write small.
Yeah.
I will say that was a guess. Like if it was a cat, rat, hat.
I'll use a word that's not really obvious. mask it.
Come down.
What does it say?
Does it say jog?
What does it say?
Jog?
No. How could you see the first word from there?
2 feet forward.
Okay, so could you please stand up?
Yeah.
Okay, please come where I am now. Okay? Can you see what it says?
Not any better.
Okay, please stand here. Okay, what does it say?
Does it say play?
Gee, look at you. Okay, thank you so much for that. I think another subject. But anyway, but what happened between those two locations? Still, my experiment worked. There's nothing really magical about it. So here it was invisible, and here it is visible. No, here.
Yeah, it was
So it's about meter and a half. Remember, we're using metric units. So, isn't it obvious that things are not visible from distance for reasons that are not terribly interesting? But let me try to make a diagram. So, from the plan view of this room, and here is my board, and here is my bird playing, and here is a person, and there's direct line of sight. Okay? Direct line of sight. So the work here was visible, maybe from this distance. It doesn't really matter. It was visible from here, and the person looking at the object approaching will keep seeing the work, right? So it was visible all this distance, right? And here it would be invisible. Now, since we don't have very large room, let's imagine if I put another subject in that corner, and he or she would approach along the straight line. Where do you think the person would see the work? At what distance? So let's call this point A, this point B, and this point C.
I would take a guess that they'd be able to see it from a little bit farther than point B, but just because they'd be straight on.
Okay, but if ceteris paribus, if all the conditions were the same, if it was the same angle, here we remove the factor from looking straight on, make completely symmetrical. Here's my board, here's one line of approach, here's the other line of approach. Okay, this is A, B, and C. At what point the person will start seeing the work?
Does it depend on the subject? Person?
The same person. Suppose the same person.
All the variables are the same, and just take compass and project that.
Exactly. Yes. It will be the same distance, B prime, whatnot. So, I mean, there is no reason for the same person under roughly the same conditions to not see work from roughly the same distance. And a few millimeters, you know, okay? So effectively, as you said, take a compass and draw this border. Now this border is of very different nature than isovist. Because isovist tells you where you see things based on your, what we call sensory access, right? Sensory access for vision has to do with a straight line or ray connecting your eye to the object. Here something else is going on. And that's where we begin understanding what space means for a biological organism that has limitations in his or her eye. Because the reason you don't see here and see here have to do with properties of your body. And it's not just the optical process. It's not just the optics of your eye. It has to do with the processing of information in your eye. So this boundary separates the range of visible and invisible. It's as if this feature, called C, has a room around itself, from within which you can see the object. And this is so simple and painfully obvious that there is almost nothing to talk about. For as long as we don't start thinking about experience of space of the person moving through it, and having practically infinite number of objects around you. So just looking outdoors, that building, look at the number of these brick tiles. Each one is a feature, right? Just, I mean, or any other tree, how many leaves on the tree to see. So the world has fantastic array of objects to see, and each of these features, objects, is just like the sea here. It has a room around itself from within which you can see it. So this boundary is a very peculiar object. And I would argue, before going into any technical details, because believe me, even a simple thing has a lot of technical details to it. Before we go into technicalities, I would argue that space of experience defined sensorially or visually is nothing but such a collection of rooms. It's like an invisible castle or some palace. It has many, many rooms with several important differences between walls of this kind and this kind of walls. Because the wall of this kind, I cannot do what I just did to this wall. Because this wall is immaterial. There are three important differences there. This wall is immaterial. You can walk straight through it without even knowing there is a wall like this. Nevertheless, it is real because you have one experience on this side and another experience on this side. The experience being knowing the word play in this room and not knowing the word play outside of the room. So this wall is immaterial, first. Second, it has this interesting temporal property in the sense that it's potential. You could be on this side of this wall, you could be inside the room of feature C, but you may not know that there was play because you didn't pay attention. So it is potential. It is potential. The walls, the physical walls like this, they're not potential. They're very concrete and real and present. And we know that very well because every time you run into the wall, you're reminded of how not potential that looks. So this wall is, it's not material, it is potential. And third, I would argue that the structure of space defined in terms of these walls is significantly more complex than what we think of the structure of material environment. Given the number of features that are contiguous in space, so this multiple, I don't know, how many tiles there on that building? Is it in thousands or tens of thousands? The features, they all the styles have slightly different colors, and they project into space for different distances. In that sense, every feature out there has a separate room, separate wall. So in reality, what you have is a much more complex reality, much more complex fabric of this reality. So let me show you one slide. I will show a slide. That slide will be. We'll come to more technical details later on. I just want to get information about it. Oh, it's on a different go. Well, you'll see it on Thursday. There was this Italian architect, Paolo Portoghesi, who made a drawing which he tried to capture its complexity. So please stay tuned until Thursday. I'll show it to you in the morning class, so you'll see it in the larger lecture in the afternoon. So there are these three features that distinguish material world from this world, which I don't know how to call really. Yeah, how do we call this world? It's not material, but it's real. What is it? Virtual? Are we talking about virtual reality? No?
It is, you're not looking at a generated image, you're looking at reality, but it's almost an imaginary wall. It's like the wall doesn't exist, but still its presence is felt.
Well, you see, when I say it's real, I do mean that it exists. It's not material. You cannot break your nose by running on pages. But it's real. Because you'll have an experience on this side and not having experience on the other side are completely real. So they're real. But this reality is of a sort of finer quality. That's why I call it virtual. Please.
Isn't it, you can kind of describe it in like ultraviolet light, in that our eyes can't perceive it, but it's there,
Yes, it's unperceptible.
like
Yeah.
on the spectrum of.
Yeah, I see what you mean. It's indeed the case that, so what happens with light, we perceive only a tiny little fraction of the entire electromagnetic spectrum. And other things we are not seeing. But maybe it's not in that case, because it's not about what we see or don't we see. Those walls are not visible in principle. You cannot perceive them in principle. They're just realized. And they're brought out of their potentiality into existence, into your experience by you moving through space. That's why it's so important to consider movement. So if I argue that these walls together constitute space of experience, it's important to realize that this space of experience is given to you by assuming that you are a moving agent, an actor, in that sense. Yeah, I see what you mean. It is like that. It's outside of our perception and it's real. Like many things. Oh, think about money. Like money. When I said the word money, imagine you have a coin or banknote sort of forming itself in your mind. That's not money. The money is it's a construct that is manifested somehow through these objects. But money is real, nevertheless. So we call them sometimes socially constructed reality. Except this is not socially constructed, because before we developed language, money, and all that, and even before humans, these boundaries exist also for animals, just as they exist for us. So, it's a funny object. Now, I want to make 2 points today. My first point is these boundaries. I just want to ask you, before I move to the motoric aspect of space, I just want to ask you, if these boundaries define experience, why do architects, when they make architectural drawings, why they draw material walls, which may be not so important, because material walls, they may not even enter your experience. So, for some reason, architects missed something essential about experience, unless they don't care about experience. But when I talk to architects, they tell me all the time that they care about experience, but for some reason they don't represent, in their architectural drawings, they don't represent essential properties of experience. So maybe this wall is an essential property of architectural design, which suggests that we need to somehow revise or reform the manner of architectural representation. And we'll do more of that conversation and a bit more technical detail on Thursday. Today, I just want to convey 2 conceptual points. The first point was about these walls, which you call virtual. My second point has to do with the motoric side of space. Remember, I told you there's sensory side of space and there's motoric side of space. Motoric or active side of space has to do with movement. Now, movement is different in the following sense. When we talk about properties of objects, those properties, or those rules, defined by the boundaries, they're centered on objects. So these rules are having objects or features in their center, and they're out there. And you are walking towards them, suppose, or passing like this, but you are passing relative to objects, and in doing so, you are subjecting yourself to properties of this object by coming in and out of those rooms. In motoric space, or active space, though those entities, they're also like rooms, walls, except they're centered on you. And how it works, I will explain using a couple of slides. How to use a couple of slides. do without an apple. We cannot do without slides. So I'll just show you a couple of slides. So I introduced it in the form of a game. In the form of a game that we designed a number of years ago to understand this motoric space. And the game was, it was actually an experiment, but we presented to our subjects, experimental subjects, in the format of a game. So here is the person. The person came to our lab. He was seated in front of a screen, touch screen. He was given a stylus, so he would not make our screen dirty by touching his fingers, right? And he was presented with this visual graphic. It's a collection of discs of different sizes. It's a collection of discs of different sizes. I'm curious whether the pointer will show on the screen. It doesn't. At any rate, I think it's clear even without it. So the game is like this. Your job as a subject is to maximize reward. This, I'm sorry. Yeah. Slides moving on their own. It's okay, go. So you are touching one of the discs, and you collect the reward. As it happens in games, you collect the reward, which is the size of the disc. The bigger the disc, the bigger the reward. Now, you are allowed next to touch only one of the two discs, which are above the disc that you've just touched. So if you touch the disc, okay? So if you moved, you could see what he touched, all the discs were gray in the beginning, and after you touch them, they become green. So he touched this disc, and then he was allowed to touch these two discs. He selected the right one because it's bigger. And then he was allowed to select one of the two discs. He selected this one on the right because it was bigger, etc. That's the game. So this is called triangular lattice of discs of different sizes, and it was scrolling down slowly. And we varied speed of movement. The game is to maximize your reward by hitting those discs. It's a simple game. Now look what happens in this computation. This is just an illustration of a little part of the game. So you start here, and then there are two discs, small and large. Now, if you think for one step into the future, you will obviously select the big disc. And then, notice, in doing so, though, you will lose an opportunity to select anything on the left side. You've heard the concept of opportunity cost, right? If you do something, right, if you go to college, you lose an opportunity to make big money right now. There's opportunity cost. So here what you did, you selected the big reward now, but you lost an opportunity to select a very big reward in the future. So if he was thinking for 2 steps in the future, for 2 steps, he would add 64 and 16, 64 and 4, 16 and 4, or 16 and 81. And results of the simple computation are shown on the side. So if you could think for 2 steps into the future, you would go to the left. You would go to college. Because your life, if you care about earnings, your lifelong earnings are much bigger if you go to college. So this is an example of simplifying the situation in which we face as we move through space or dark. Because every time we move, we perform any action at all, such as drinking coffee, writing, drawing, scratching your head, every action whatsoever normally consists of multiple steps. And without you knowing that, your body, your whole being, is continuously computing consequences of your actions. And these consequences are valid in the sense that you prefer one action over another for a reason of saving energy or whatnot. Even the simple act of picking this object, you see, I could do it in infinite number of ways. I could do it like that. I could do it like that. I could do it like that, which is not very efficient. So my body is computing all possible ways, maybe not all of them, but many possible ways of doing an action, and then it selects an action which is rewarding in some sense, maybe in terms of saving energy or time or whatnot. Or in terms of what I'm going to do next, okay? So if I'm going to write with the spec, I would rather pick it like this, right? Rather than pick it like this, then take off the cap and then turn, right? So whatever we do happens in the context of what we're going to do next. So this game is representing these aspects of your action, and I think it gets at what it means to have an active motoric space. Because all these possibilities for action are normally, not always, but in case of you acting in the world, they're distributed in space. There are many points of contact on the span, okay? There are many ways to move my hand through space, and then I have to turn and write on the board. And this, I would argue, is the beginning of understanding what sensory space is, right? So we're going to do a little exercise. I will just want you to appreciate the nature of this computation because it will be essential for understanding the next step. So this is just an exercise. Now, if you had the depth of 1, please tell me, on the left side, where would you end up?
If you could only think about your next step.
Yeah, thinking every step, you think about just one step. So where would you end up on the last row?
The 2 at the top.
2 at which left
The
or right?
middle one.
Middle 2.
Sorry.
Okay. We consent? Technology experiments. Okay, hit space. Yes, you're right. Because you obviously select the biggest circle matter step. What about the middle? If you think about 2 steps in the future. So here, you can actually draw a diagram on paper. You can show in 1 to 2 is 3, then add 3, 6, etc. So you could draw it. I'll give you a little more time. You have an answer? Please.
Find these all identical.
Huh?
They all identical.
Identical? Maybe.
At least the answer I found would be the same. You get there different, but you end up the same.
Here.
Yeah.
Okay. Are they this? It's a little more difficult. Right? Why is it so?
You're mapping out not just you're not binding yourself to one action, you're binding yourself to, you're further limiting your path.
Right, but as you're doing so, you have to consider more possibilities, right? So stop torturing you, right? Here's my answer. Oh, that doesn't work. Okay. No, maybe it just doesn't, right? Oh, it works. Okay, so you end up here because here beyond this row you can compute for 2 more steps, but you stop here because you see. So you have to compute 1, 2, 3, and 4 possibilities. So in every step you have to compare 4 possibilities. That's why it took you more time to compute. Okay. So the correct answer, and if you can check it, you can take a picture and check it. This is where you will end up. Now, if your depth is 3, I will not even ask you to do that because it will take a very long time. And here is the answer. You stop here because, of course, you will have 2 more steps to go if you don't have the 3rd row. But to figure that, of course, you have to compute many more possibilities. And you could, it's also it's an exercise to compute how many possibilities you need to compute in order to get the answer. So what I'm getting at is that for a creature that's not thinking about one step in the future, but for more than one step, you need some brain power you need some computational resources in your body in order to move around. And that's what our bodies are doing all the time with calculus. But with it comes a limit, because you will notice that if I keep growing the tree, the farther you compute into the future, the number of computations you need to perform in order to make one step will increase exponentially. So the future for an agent like this, moving in space, computing possibilities, is unknown, not only because the world is unknown somehow, or limited. The world is unknown because there are cars driving here, you're crossing the road, you have to look, you know? It's not enough to stand and compute, you have to look because the car could emerge any moment. And those proverbial bricks are falling from the roofs and all that. The world is unpredictable to some extent, but your future is unknown also to the extent that you cannot compute it. You don't have enough power in your body, in your brain, to consider all the possibilities of future action. In that sense, there is a computational limit that surrounds your body that has to do with the relationship between the here and now and the future. So you compute for a certain number of steps in the future, and this is just like this boundary. Except, as I pointed out, this boundary is centered. You're the agent, right? You're the agent, and you're moving. So on every step, you have this in here, there's another boundary. This space around you is bounded by your limited computational resources in terms of figuring what you want to do in the future. Just like sensory features are limited. So what you have in the end is a situation in which the space that surrounds you is crisscrossed by those virtual boundaries. One class of these boundaries is sensory, having to do with distance from the objects out there, features out there. The other set of boundaries is motoric, that surrounds your body, and they depend on what you want to do in space. So if you want to talk about complete picture of space, not only sensory, not only motor, but sensory motor, which is actually the space in which we inhabit. This is the space in which we move, look around. This is the real space. That space is defined by these intersecting boundaries, which are not material, which are potential, and which create a picture that is rather complex. So what I want to do today is just to present these two ideas to you. And we're going to do things with these ideas on Thursday. Because both of these ideas, I think they could carry us long distance into understanding what the future of architecture is going to be. One way or another, scientists will invade architecture, our understanding of how we perceive things, how we act in the world. Coming from science, they will affect architectural profession by means of plugins in your software, or by means of how you are taught to make drawings, and all of that. But essentially, this is one of the first contacts that we are exercising here in this class, and this is the beginning of understanding of how to conceive space sensorily and motorically, or actively, from the point of view that I would not say really scientific. I happen to be a scientist, and I do these experiments. So everything I'm saying in this class is a result of doing some experiments in the laboratory. But the result of this thinking, it's not intrinsically scientific. I think it has to do with our immediate experience, with the here and now. It just so happened that for one reason or another, architects, designers, didn't come to thinking of this stuff, even though they do care about experience. They do care about other aspects of experience, such as proportion. Tiziana and I studied proportion. We'll talk about it next time. But proportion, just like any kind of feature, it divides space around itself to those parts of space within which proportional structure of this object cannot be experienced at all. Maybe because you're looking at that object at an acute angle. This rectangle has a proportional relationship to it, right? Obviously. Now, if you turn it, then more and more, you'll not be able to tell it. So if it was object in space and you're moving around here, the space in front of the object would be divided to zones. In some zones, this proportional property would be accessible, in others it would not. So again, it doesn't have to be a single feature. We will play written on a whiteboard. It could be any feature at all, including such a complex feature as proportion, which is in itself already a relation between the distances. So we have a few minutes. I just want to anticipate what's going to happen next, and then maybe we'll discuss a few things, we have questions. So next time, I would suggest how we think about your specific projects that you started to develop in terms of the structure of space, sensory and motoric space. So you imagine people are moving through that space and subject themselves to those properties of environment which you decided to investigate in your projects. So we'll try to invent new ways of architectural representation, which should have been invented maybe hundreds of years ago, maybe longer, but for one reason or another didn't get to be invented. Okay? So that's what we're going to do next time. And let me ask you if you have any questions about what we discussed so far.
You have one of the placement of our virtual wall, so up there on the board. And I guess my biggest, I don't understand exactly why the wall is focused around the object as being viewed and is not focused out from, like in the same arc, out from the standpoint of the viewer. Because, you know, that wherever I am, if I'm moving along that arc, maybe it's two concentric arcs, two separate walls, but would the wall not be defined by the experience of the person viewing it rather than the object being viewed?
Well, it is in fact defined like this, because if you say you're a static person standing here, okay, M, or a person standing here, M, the M, okay? So you are, from the perspective of the person standing there, you cannot see the feature. You could, of course, take the perspective of the person, and all you can say about that is very basic level of analysis, that you cannot see the feature. And you could be anywhere here outside of the wall, and the statement will be true about you not being able to see, and vice versa. But what you're saying is very interesting, nevertheless, because what we do here is we mix two fundamentally different ways of thinking about experience. One is objective, another one is subjective. Now, if you studied anthropology, in anthropology there's a concept of emic and etic. Emic and etic. So if you are an anthropologist, you study some culture of interest, you could describe it from the emic point of view. It comes from phonemic, and it's a linguistic term. Emic. You could study it from the perspective of people who inhabit that culture, right? So we're talking about space. We are all here members of this culture. We are a culture of spatial beings. We all experience space, and this is our subjective point of view of people from inside, as you look out at the room. And just like you said, from that point of view, you just define what happens as you stand there. You can see or cannot see the feature. What they describe here as this boundary, this is the etic approach from the outside. I am hovering above space. I am the designer. It's capital letter D. The architect is capital A. And I know what's going to happen at every point in my space because I'm designing it, right? This is my etic, objective view of what all these people at every location are going to experience. Because I want to design this experience. So you're absolutely right. We could take both points of view, subjective or objective, emic or ethic, and the whole game about it is essentially about the relationship between the two. Because when you design for people who are going to inhabit what you're designing, they're going to experience it from the personal, first person point of view. So it is indeed the case that we should constantly switch the perspectives, the objective and the subjective. Any other questions, please? So, if it's also clear, I'll have a question for you. Isn't it the case that architects care about experience?
Yes.
So why don't they think about experience in terms that define experience? There's an answer there.
I would argue that some do. I would argue that like the people that lay out museums, they're thinking about the fact that you'd be able to see the painting from very far away, but to read the plaque that like tells you information about the painting, the artist's name, where he's from, a little bit of background, you have to come much closer to pass that barrier for the plaque to be able to read it. So they're kind of pulling you in and out across the gallery space so you can read all the information of all the things. So I would argue that some do, even if it's unintentionally.
Yeah. Indeed, so what we're appealing to is the whole science of museology and exhibition design, and I don't think this profession qualifies as architecture, but that's what these people care about, indeed. And by putting these little labels next to paintings, making those labels larger or smaller, they essentially control your behavior. So if you observe what people do in the museum, those who care about who created this art, people do, they behave, it's almost funny how stereotypical it is. People come to the painting, then they dive for the label, they do this, they look at it, and they come back. Everybody is doing that. Nowadays, they also perform this movement. They don't even look. They just take the snapshot, and that's how they. But these are behaviors that are triggered by a designer. And museum is a very clear case of that. I completely agree with you, because there the point is about organizing the space for viewing. But let me generalize and suggest that architecture generally is about that. And to my knowledge, architects, as they design it, rarely they perform this kind of analysis. And when architectural work is presented scholarly, artistically, in albums of architecture or in portfolios, it's presented in a way that gives you no clue whatsoever about experiential structure of the space that surrounds these buildings. They give you several canonical views of the great design, maybe they do sometimes. Some architects in their work, they do perform what's called sometimes vignettes, right? They draw. So in my talk on Thursday, I will show drawings of a Portuguese architect, Caesar, Alvaro Caesar, that is well known for the whole albums of his drawings published, where he shows how a person approaches a building from several points of view, creating sort of visual narrative, and that's the beginning of this analysis. Even though it's completely the point of view of just like the previous question, it's a completely point of view of the person. But the space is organized in a particular way, which gives you an extra power. If you knew how to present that, it would give you extra power in terms of anticipating experience. There's a question here.
You brought up the question, why not just use the mental experience of a wall and use the physical wall? I would, in my opinion, argue that the wall itself is a part of the experience. It's just that we go for different experiences. If you're going for a private experience, we use the physical wall. If you're going for a communal experience, we kind of use those mental barriers rather than walls. So I don't think the wall itself takes away from the experience. I think it just specifies what experience we are trying to aim for.
I see what you mean. Yeah, and it's very interesting that you appeal to communal experience. Because I would argue that this representation, the ethic or objective representation, it tells you about what anybody who is same kind of vision, is a healthy, normal vision would experience at any location. So you can think of that as what they call intersubjective. Subjective means that it's in your mind, it's on the point of view to which you have a privileged access, right? Privileged access means that only you can know your thoughts. You have a special authority over your thoughts, and that's subjective point of view, your thoughts. Objective is an attempt by scientists, not only scientists, but scientists in particular, to get outside of that. Create objective science. You have to create a picture of the world, which is not about perception of a single person. It's not about idiosyncratic picture by that person, but about perception by everybody. So there's a philosopher, Thomas Nagel, at New York University, who described this point of view as a view from nowhere, because it's view from every point altogether. And from the point of view of some other school of thought, of phenomenology, which you mentioned, objectivity sometimes it's described in terms of intersubjectivity. So phenomenologists, some of them, they reject the scientific concept of objectivity. They replace it by what they call intersubjectivity. Intersubjective is the experience that we have together as a culture. And that's maybe what your question appeals to. So I would argue that this representation is intersubjective in that sense, because every person with normal vision, of course, very, very young children and elderly people whose vision fades, would have these boundaries shifted. And we know what on average happens to people in those ages, and we know where to place those boundaries, and I'm going to talk about this next time. But I would argue that this representation is indeed communal in that sense. And it's not surprising that architects represent material objects, but if they care about experience, not only about shelter or other specific functions that are not experiential, then they should be interested in presenting the structure of experience, because it's real and it's present. And what's curious about it, before we close, I just want to point out one curious feature of this. So remember I wrote the word plane, and there was a boundary in space which we drew here. Now, when everybody left the room, and no one left, no human being, unknown human being is left in the room, would that boundary still be present? Yeah, you're thinking about that tree, right?
Yeah, actually.
Yes, you do. Yeah. So, would that boundary be present?
I would say no, because that boundary is a mental boundary that we put in our personal spaces. So the boundary of the room is still there, but how the subcategory of the boundaries in the room don't exist anymore. And when another group of people come in, those boundaries don't just come back. They're a different set of boundaries now, depending on the observers in the room.
But suppose, just for the sake of the experiment, you're all young people and you all have normal vision corrected to tremendous extent. You have perfect vision, right? All of you, yeah. You have very good vision here. And suppose you have all the same vision. If I took you to the optometrist right now and he tested your vision, he will get exactly the same result. Suppose that, just for the sake of the experiment, to simplify matters. Would that boundary be there still? Every student in the college will have the same vision. And in the entire University of Oklahoma will have the same vision. For those students who are not present in the room, would the boundary still exist?
Yes, because the second they step in the room, they are in that boundary. It's going to become a universal boundary.
Yes. And I would agree with you, and I would say more, that that boundary will be present there even before they step into the room. This boundary is a property of architecture, just as the actual tectonic walls, tectonic objects, are properties of architecture. The difference is, as I mentioned that these boundaries are not material, which makes them kind of fine and hard to grasp. They're still real. And they're potential. Potential means that nobody has to be present to experience them. They're still there. And I have an equation, I can tell you, we'll talk about this next time on Thursday, I could actually write an equation that will tell you where this boundary is for a person with normal vision. It's that real. It's as real as material walls. So if it's that real and that replicable, I think it's almost a sin to not represent it in your design if you care about experience. Was not the question?
Oh, well, yeah, okay, so the thing you just said, you said it would be a sin to not represent it. How would you go about representing it? Do you take it in mind when you design, or do you literally put something on the floor?
That's a great question, and that's what we're going to do on Thursday.
And then my second one was, I don't know, playing devil's advocate. The same way that we subconsciously know what space is, but we don't know how to define it. Can't you also argue that designers have been considering this concept of an invisible wall, but don't exactly know
How to
why
explicate
they did it?
Yeah. Maybe it is the case. It's a very interesting question. You mentioned the concept of unconscious or subconscious. This is an important part of it because this boundary is not sharp. If I could measure, which I'm going to do, if I could measure the degree to which you could see, with the word play, it's play or you don't. But if it was something else, and that's something else I'll show you on Thursday, okay? If it was something else in which you could measure the degree to which you can see, I would discover a smooth function, which is called psychometric function, which describes the probability or likelihood of you being able to see that as a function of distance. So if I draw that function on the slide, so this is 0, this axis is going in this direction, okay? If I draw it like this, as a scientific graph, this is distance going there. And visibility, if this is 0, okay, the farther away, the less I see. So I move away, here's my boundary, right? This is visibility. So I move, I see, and then there is this transition. It's a smooth transition. It's generally the case if you know how to measure it. This is called psychometric function. It's just usually it's drawn as a growing function, but it doesn't really matter. So this boundary is very interesting because here, for example, you'll have to define where you see it. So, for example, if I measure a fraction of cases where you see it, say 75% would be considered I can see it. So 75, this is 100%. So this is visibility measured in percent. And this is, say, 50. 50 means it's not 0, 50, because if I don't see it, I say it correctly and correctly, a chance. I'm correctly 50%. So if I define visibility at 75% here, that's my boundary. But here you'll be correct at 80%, and here you'll be correct at 70%, right? So your ability to access a feature, you move through space, in most cases is a smooth function. And here, if you are in your psychoanalytic mood, sorry, for 5 minutes, maybe. This mic goes on the floor. Maybe for less than 5 minutes. So you could think of this as consciousness. This is unconscious. There's no way you can see it from here. Conscious, unconscious, and here you have the situation for which psychoanalysis could say something, but I would not use psychoanalytical language. But it's really what they mean by sort of near-conscious experience. And in architecture, you have the concept of threshold, right? Threshold architecture is about transitions from one space to another. So it's used, for example, in analysis of sacred spaces, etc. You could think of that perhaps as a threshold, which is not physical. So maybe it's a new way of thinking about thresholds, which makes even more sense, because in my science called psychophysics, this boundary between visible and invisible is called the threshold. Maybe it's just a coincidence. But about architects having that in their minds and probably not knowing how to express it, I do believe that it is the case. And if you study history of architectural thought, you find many examples of they trying to say that. I think my presentation didn't play back to me, but it's okay. So what I'm trying to say is this. If you read history of architecture from the time when they started to use concept of space, you discover many instances where they were talking about experience of space in very similar terms. And just one name I want to give you, because we're running out of time, it's August Schmarzow. August was one of the founders of this German aesthetic movement. August. Schmarzow. It's German name, I think it's SCH, but
Yeah.
it's like this, yeah. August Schmarzow, there is an article which you could share with the class if you're
Yeah,
interested.
I have it.
So he was talking about what I'm saying in similar terms, except the science of psychophysics and systems neuroscience was not developed yet. So he didn't know how to say it precisely, but I think he was trying to do that. And the article that I'm alluding to was written, I think, in 1893 or 4.